Hello, my amazing Algebra 1 students. This is Mrs. A, and I love math. Today, we're working on lesson 20 in your Saxon orange math book. And there's just a little bit of a glare on my board because I am enjoying the great outdoors here. And I'll try to keep the glare off as much as possible. But we are talking about volume of a geometric solid. So remember, a geometric solid is a shape that is going to be the same all the way up and has volume, which means that it could hold a number of cubic units contained is the volume. So it actually has length and width and height in order to be a geometric solid. It is not a two-dimensional figure that is flat. So a cube is a good example of a geometric solid, and it has 6 identical square faces. We will test my cube drawing skills. But to draw a cube, we often will start with a box, and then from our box we will go and do the sides like that. And that's a pretty good cube. Not a great cube, but it's pretty good. But remember, we're seeing through this cube. So this cube has got sides that we can't see. My marker's about to die. Okay, so the back sides of the cube we can't see through my solid cube, but we could pretend the cube is transparent, and then we could put little dotted lines to show the cube connecting. Okay, so the cube has a front side, a back side, a top side, a bottom side, a right side, a left side. 6 identical faces. So when we're talking about units of measure, length is always measured in units, whether it's inches or feet or meters. Area is always in square units, and volume is always in cubic units. So let's talk about on page 87, they're talking just a little bit about right solids. And a right solid is a geometric solid that has right angles. And so a cube would be a right solid as well as a geometric solid. The bases, if the bases, which are both the top and the bottom of this right solid, if the bases are polygons, which means there's no curves. Remember, we talked about polygons being simple closed figures that have only sides for lines, only lines for sides. I said that backwards. And if we have bases that are polygons, then we have a right prism. A right prism. And the volume of a right prism is area of the base times the height. So area of the base times the height. Now we're doing problem 20.1, and we're looking at the base being an isosceles triangle. So you can see I drew 4 centimeters, 8 centimeters in height, and the 2 sides opposite are the same. It is a right isosceles triangle, and then the height of the whole shape is going to be 6 centimeters high. Now you have a really good picture of this in your textbook, so I didn't bother to draw it because I'm not a great artist. But this is just the base of the figure, and then the figure rises up off the board by 6 centimeters. So now how are we going to find the volume? Okay, remember that the volume of a right solid is going to be area of the base times the height. So the first thing we have to do is find the area of the triangular base. The area of a triangle is 1/2 base times height. On our triangle, we'll call the base 4 and the height 8 centimeters. So we have 1/2. When we do that calculation, we have 1/2 4 times 8, according to our figure. And 1/2 of 32 is 16 square centimeters. Remember, area is always in square centimeters. So now we're going to take that area and multiply it by the height of the entire figure, which is 6 centimeters. Remember, this is just the base, and then we've got to raise it up 6 centimeters. So we're going to multiply this 16 square centimeters by the height of the whole figure of 6 centimeters. When we do that, we've got 16 square centimeters times 6 centimeters, and I just put that in parentheses so it's a little bit easier to see. And when I multiply that out, I get square centimeters times centimeters is cubic centimeters, so I get 96 cubic centimeters. So I can write out cubic centimeters, or I can write centimeters cubed. Okay, this is 20.2, and this is a fun one. We are on page 88 now, and we have this being the base of a right prism, and the whole right prism is going to be 8 meters high. So think of this as the base, the bottom looks like this, the top looks like this, and then the whole thing is 8 meters high. So in order to find the volume of this figure, the first thing we're going to do is take our shape and turn it into a rectangle and then a triangle attached to it. And then we'll deal with this at the very end. So we know that this is a right figure because it shows it being right on your book. I just forgot to draw them in. And when we do a straight vertical drop down, this is also 6 inches here. So 6, I guess this is all in meters because it says that the units are in meters. So this is all meters. So now let's look at a little bit of math here. This whole thing is 10. But this right here is 4, so doesn't mean this part that we've just sectioned off must be 4, and this part over here must be 6 to make the 10 altogether. So now we have our rectangle that is 4 by 6, and 4 times 6 is 24, so that is 24 square meters in there. And then we have a triangle that is also a right triangle. So we're going to say, what is the area of a triangle? Well, it's 1/2 base times height. So we're going to have 1/2 6 times 6. And 1/2 6 times 6 is going to be 1/2 of 36, or 18. So we'll just put a little 18 in there and a 24 there. When I add the whole area of this figure together, then I'm going to get an 18 plus a 24 is going to give me 12, carry, and a 42. So I have 42 square meters because it said that dimensions were in meters. 42 square meters, and then I'm going to multiply by the height of the whole object, which is 8 meters high. So to do the math, we're going to have 42, and we'll just do it down here, times the 8. And 42 times 8 is going to be 16. And 32 plus 1 is 33. So the volume is now cubic, because remember this was meters again. So we've got square meters times meters is cubic meters. Okay, and there we have it, 336 cubic meters. Wow, this figure is really big because it is in kilometers. This is 20.3 in your book on page 88. And here is the base of the figure, but everything is in kilometers. And kilometers, remember, 1 kilometer is 1,000 meters. And then the height of the whole figure is 10 kilometers high. Wow, this is big. So let's find the volume by first finding the area of this base. So we have broken up with a dotted line this rectangle added to a half circle. And because the half circle is 3 in radius, I would have already known that this must be 6 because the radius would go here and then down here. But they told me that that was 6 also. So now we have in here 6 times 5 is 30. So that's 30 square kilometers. And then the area of a circle is pi r squared, right? That's the area of a circle. And so our r is 3. So I get pi times 3 squared, but 3 squared is 9. So I get 9 pi. And we're doing an approximation here. So we're going to go ahead and multiply 9 pi out. And we're going to use 3.14. So 9 times, well, let's do it a little bit lower so I have room to multiply. 3.14 times 9. Okay, so 4 times 9 is 36. Carry the 3. 9 plus 3 is 12. Carry the 1. 3 times 9 is 27 plus 1 is 28. So we'll put our 28. And then we're going to do the whole thing by 9. No, we already did it. Sorry, I'm done. So we're going to move 2 decimal places. My bad. Okay, so we have 28.26. That is this right here. So let's write this down. 28.26. But now I have to be very, very careful. You see right here, I just found the area of a whole circle that has a radius of 3. But my figure only has a half a circle that has a radius of 3. So I need to now cut this area in half. So I'm going to end up with 14.13. And I'm going to add that to my 30. And when I add it to my 30, I'm going to get 44.13. Okay, so now we have accurately gotten the area of the base. And now we have to multiply by the height, which is 10 kilometers. So we're going to take this and multiply it by 10 kilometers, which simply is going to move the decimal 1 place to the right. So we will have as our final answer 441.3. Let's write it up here. 441.3 cubic kilometers. And that is a done deal. So let's review. We started here, got the area of the rectangle. We got the area of a circle with 3 as the radius, but then we had to remember to cut that area in half. And we got the 14.13. We added the 14.13 to the 30. And this was our area of the whole base, which gave us square kilometers. And then we took this and multiplied it by the height, which gave us cubic kilometers, and 441.3 cubic kilometers. Done deal for 20.3. This type of problem I really love. We are on example 20.4 now, the next to the last problem in this section. So we're now talking about a right circular cylinder. So the area of the base times the height still holds. We have a circle with a radius of 6 inches, and of course that circle is the same circle that appears on the top, even though Mrs. A can't draw it very well. But this one is also a radius of 6. So the same on the same base and the top. These are both called bases, remember, on a right solid. So now we're going to have area of the base is the area of a circle. So pi r squared is the area of a circle. And so we're going to have pi times 6 squared, which is times 36. And when we multiply that out, we're going to have 3.14 times 36, which is going to give us 24. 6 plus 2 is 8. 3 times 6 is 18. And then we're going to do the 3, which is going to be 4 times 3 is 12. We move in 1. Carry the 1. 1 times 3 is 3, plus 1 is 4. 3 times 3 is 9. And now we add them all together. 4 and 10. Carry the 1. 12 plus 1 is 13. Carry the 1 and 11. And we have 2 decimal places. So 113.04. And now this was in inches. So this is in square inches is the area of this circle. And now we're going to multiply that by the height, which is 11. So we're going to multiply by 11 inches. So the square inches times the inches will give us the cubic inches. And when we're going to go up here and do this, 113.04 times 11 because we ran out of room down there. And this one's particularly easy, right? Because we just do 4, 0, 3, 1, 1, 4, 0, 3, 1, 1. Okay, so I ran into my other thing over there. Let's take it off. So here we go. 4, 0, 3, 4, 2, 1. 1, 2 decimal places. There is my answer. And that answer is in cubic inches. So let's make inches cubed right there. So we have 1,243 and 400ths cubic inches. So again, let's recap. Area of the base is a circle. The area of a circle is pi r squared. We put that on there. We calculated it out. And we got 113.04. Then we multiplied that times the height, which was 11. We did that up here, and we got our answer right there. And that was example 20.4. This one is particularly easy because although we have a very weird shape, they already gave us the area of the base is 52 square feet. So now all we have to do is take the area of the base, multiply it by the height. So our answer is going to be 52 times 15. And now since we're taking feet squared and multiplying by feet, we're going to get an answer in cubic feet. So all we have to do is do the multiplication. 2 times 5 is 10. Carry the 1. 25 plus 1, 26. 52 times 1 is just the 52. And 0, 8, 7. 780 cubic feet is that answer. So that was example 20.5, and that one was the last example, and now we'll do some practices. Okay, so now let's do our 3 practice problems, and you can see the base of our figure here, and this is a right solid, and then we have the figure is going to be 10 inches high off the ground. All of the dimensions are in inches, so we don't have to do any conversions. So the first thing we would do is find the area of our base because we know the volume is area of the base times the height. So here we have a rectangular portion. So 4 times 10 is 40, and that's going to be 40 square inches because everything is in inches. And then we have a half circle. Remember, the area of a circle is pi r squared. So the area of a half circle would be pi r squared divided by 2. So now we're going to just plug in the 2 here, and we're going to take out our r squared and put in 2 squared, which would be 4. And the 4 and the 2 cancel, so we're going to end up with 2 pi. And when we multiply 2 times 3.14, we get 6.28. So we're going to add the 6.28, which has already been cut in half, to the 40, and we're going to say the area of the whole base is 46.28. And then we're going to multiply the 46.28 times the 10, that is the height. And remember, when we multiply by 10, we simply move the decimal 1 place to the right. So multiply by 10, and we get 462.8. And this one, remember, area is inches squared, and then volume is inches cubed. And that would be our answer, 462 and 8/10 inches cubed. Here's the next practice problem, and this is the way they give you the picture in the book. They tell you that you have a radius of 6 and a length of 20. Okay, now when we're thinking about our formula though, remember our formula is area of the base times the area. We'll put a little b here, area of the base times the height is the volume. Okay, so remember, it's easiest to think of this picture up here as standing up on its base. Okay, so we stand it up on its base so that we can use the formula area of the base times the height. Now you can use the same thing with this figure, but we always think of a base as something that the figure lies on, and the base is here and here, but it's not what the figure is really lying on. So to me, it's a little easier to think of it this way, where you put it vertically. A right circular cylinder is right here, isn't it? This is the right angle as it touches the ground right there. The ground makes a right angle with the height. So to me, it's easiest to visualize the figure this direction. So now the area of the base, that's the area of the circle, and it's going to be pi r squared. And so we'd have pi times 6 squared, which would be 36 pi. And that would be the area of the base, and then times the height. So the height is 20. All of this is in the same units, okay? So now we've got the area of the base times the height. That should be our volume, which if we were going to leave it in pi, and sometimes we do leave it in pi, we would get 720 pi. Okay, now I'm not going to multiply that one out for you, but if you were going to multiply it all the way out, it would be 720 times 3.14. But actually, I want you to think about this. When we have pi in the answer, it is an exact answer. When we use 3.14 in the answer, we're getting an approximate answer. So sometimes as you get higher up into math, they will tell you to leave the answer in pi. So you have to watch carefully for your instructions. We will either use 3.14 and multiply by 720, or we might leave it with pi in the answer. Here is the very last problem. Okay, I lost the post to my tripod, and that's why I'm having a little bit of hard time tonight, but I will get a new tripod and we'll go back to normal. But for right now, I'm hoping this is getting across to you. So here we have a very weird shape for the base, but that's no big deal because we have been given its area already. It is 50 centimeters squared, and then the height of the figure is rising up off that base 12 centimeters. So we're going to take our area of the base times the height, and we're going to multiply, and 5 times 12 is 60, so 50 times 12 is going to be 600. So we're going to have 600 centimeters cubed, and that should be our complete answer. So that would be our volume is 600 centimeters cubed. And that is the end of lesson 20. And this is Mrs. A, and may God bless your day.